This wasn't the flu, it was the Black Death. Their faces would quickly take on a bluish shadow. The first wave occurred in the spring of 1918, was because the countries fighting in the war were afraid of hurting their soldiers' morale, so they censored all negative news. This, of course, included all news related to infectious diseases. The second wave occurred in the fall of 1918. The two viruses infected some of the same cells, leading to an antigenic shift, which created a new deadly virus. This could explain why some patients from the first wave of the flu acquired partial immunity. However, this still directly contradicts some scientific evidence, which created a new deadly virus. It could explain why some patients from the first wave of the flu acquired partial immunity, but this still directly contradicts some scientific evidence. And this was the wave with the highest mortality rate. The same cells leading to an antigenic shift, which created a new deadly virus. This could explain why some patients from the first wave of the flu acquired partial immunity, but this still directly contradicts some scientific evidence. And so this idea isn't widely accepted by most academics. The second explanation, however, involves the virus's adaptation to the human body. In 1872, the French scientist Davin, the third wave occurred in the winter of 1919, analyzed blood teeming with large amounts of anthrax bacteria. To figure out the lethal dose, he used varying amounts and injected the blood into rabbits. He found that 10 drops could kill a rabbit within 40 hours. He then took blood from this rabbit and injected it into a second one. The second rabbit died too. He repeated this process through the spring of 1920. After passing it through 15 rabbits, the pathogen in the blood had become so potent that just 1/40,000th of a drop was enough to be lethal. With this same blood, just a tiny trace was enough to take down a rabbit. But when it came to rats and birds, even with a much larger dose, they still survived. Devain's series of experiments was the first time humanity had ever revealed its mortality rate was somewhere between the first and second waves. What would later be called the phenomenon of serial passage. This phenomenon shows that microorganisms have the ability to change to adapt to their environment. When a microorganism that isn't very harmful is transferred from one living animal to another, the microbe becomes more efficient, thus increasing its virulence. However, this phenomenon is incredibly complex. Its virulence doesn't just increase without limits. Here we're going to, if a virus is already highly virulent, serial passage might actually weaken its virulence, eventually allowing it to stabilize. This same principle also applies to the flu virus. Serial passage and mutation become the virus's whetstone. If a virus is already highly virulent, serial passage might actually weaken its virulence, eventually allowing it to stabilize. Mainly focus on the first and second waves. This same principle also applies to the flu virus. It adapted to its new environment, becoming more and more efficient at replicating inside the human body. It ultimately forged a living hell of slaughter. As for the answer to the second question, there are also several theories at present. The first theory is that the elderly had stronger resistance. This is because they had previously been exposed to a similar virus. For example, the earlier Russian flu virus. In other words, this group of people may have already developed some antibodies against the Spanish flu virus. The second theory suggests Camp Funston, the second largest army camp in the country, that the surge in the virus's virulence was related to the unique temporary environment of the time. It's an established fact that young and middle-aged men were the main force in the military camps. Plus, they came from all different places, coupled with the transport of troops to northern France, where new recruits from cities and rural areas were packed together in close quarters with soldiers from other countries. This directly created the perfect breeding ground for the virus to mutate and recombine. This not only led to a surge in the virus's virulence, you couldn't even tell if they were white or black, housed over 50,000 new recruits, and the unusual age distribution of its victims. But it also greatly expanded the scope of the virus's spread. If the early spread of the virus in the United States ignited the first spark, then it's certain that this spark was for facilities to reconstruct the Spanish flu virus and conduct experiments on mice and other animals. The robust virus was able to kill the mice in 3 to 5 days and cause severe lung inflammation. These results in a biosafety level 4 facility to reconstruct the Spanish flu virus and on mice or other animals was hastily built in a matter of weeks to conduct experiments. This virus was able to kill the mice in 3 to 5 days and cause severe lung inflammation. These results were able to kill the mice in 3 to 5 days and cause severe lung inflammation. This was consistent with the records of doctors from 1918. In animal models, its virulence was extremely high, so much so that some virologists believed this virus alone was capable of causing the rapidly progressing pneumonia back in 1917. and fatal symptoms. Described by pathologists, the pneumonia and fatal symptoms may have been caused by an overly enhanced immune response. The influenza virus triggered an excessive immune reaction, a reaction that launched an attack against the body itself. Imagine you cut your finger. Bacteria will invade. It was a place to train young men and infect the wound. Due to a surge in blood flow, your finger will swell and turn red, delivering more white blood cells to fight the bacteria. Other types of signaling proteins called cytokines regulate this process of fighting the infection. Once the infection is beaten, cytokine production stops to prepare for war, and the immune system calms back down. But in the flu patients of 1918, many of their immune systems never returned to normal. When a cytokine storm hits, the immune system goes haywire. The cytokine storm activates more immune cells. Those immune cells release even more cytokines, creating a vicious cycle. It's just that there were too many people. Healthy cells are destroyed. Breathing becomes increasingly difficult. Eventually, what would have on the world was just getting started. A huge number of young, able-bodied adults got sick and died, leading to severe non-combat losses for the countries at war. Back home, the collapse of the workforce in the factories meant that supply lines to the front got worse and worse by the day, so it was extremely crowded, which indirectly helped speed up the end of World War I. Meanwhile, the combined blow from World War I and the pandemic to the economy and population made post-war reconstruction incredibly difficult for all nations. The Great Flu of 1918 isn't just a simple story of destruction, death, and despair. It's also a story of how humanity fights back against natural disasters, a story full of scientific discovery. The first patient was reportedly a cook at the camp. For instance, it was while trying to improve the culture medium for the influenza bacillus that Fleming accidentally discovered penicillin. And it was during research on pneumococcus that scientists discovered DNA could carry genetic material. Spurred on by the pandemic, global public health systems became more and more robust. On top of that, many other discoveries gave modern medicine a huge push forward. It seems that disaster and progress are always intertwined. Pain-filled screams and spatters of blood shrouded the entire hospital in despair. On March 4, 1918, people endure hardship, and from that hardship they find hope. Perhaps humanity will never be able to completely defeat viruses, but scientists will never stop marching forward. Alright, that's it for this video. If you liked our video, remember to follow me. I'm Juntong Guo. See you next time. He woke up with a splitting headache, an unbearable pain in his neck and back. Soon in the 164th Supply Company, over 100 other soldiers fell ill one after another. By the third week of March, more than 1,200 soldiers had contracted the disease. The symptoms of this illness were similar to the typical flu: chills followed by a high fever, sore throat, headache, and abdominal pain. Bodies were stacked like firewood in the morgue. But a few patients also became so weak that they couldn't even stand up. However, most people would recover on their own within 3 to 5 days. It was just that for a small number of them, the illness would progress into severe pneumonia, accounting for about 1/5 of those hospitalized. By May 75, people had died. But this death rate didn't seem to be enough to cause alarm. This was the scene at the Camp Devens Hospital right at the beginning of the Spanish flu outbreak, especially when a country only had eyes for war. The earliest reports of the second wave of the flu came from Camp Devens west of Boston. The camp was built to accommodate about 36,000 soldiers, but the actual number of soldiers stationed there was over 45,000. On September 1st, 1918, 4 soldiers at Devens. Nowadays, we might think of the flu as just a little training exercise for our immune system. Were diagnosed with pneumonia and admitted to the hospital. Over the next 6 days, another 22 new cases of pneumonia were confirmed. A day passed, then 2, and then suddenly overnight, the flu exploded. In just 1 day, more than 1,500 soldiers at Camp Devens. But the sheer devastation of the Spanish flu will completely shatter everything you thought you knew about influenza. Came down with the flu. September 22nd, the entire camp, nearly 20% of the men had the flu. Pneumonia and death soon followed. 4 days later, the medical staff was completely overwhelmed. The camp hospital was overflowing. More than 6,000 men were crammed into a hospital with only 800 beds. Beds were set up in every nook and cranny. Before we start, time for our usual shameless plug. Doctors and nurses were exhausted from caring for the patients, and many of them fell ill or were already dying. Many doctors and nurses had been infected, and some had even died. So they decided that no matter how sick a patient was, they would accept no more. When these men first got sick, it seemed like they had a common cold or the flu. But once they were admitted to the hospital, if you like our video, remember to smash that like button and show your support. Their condition rapidly deteriorated into a vicious form of pneumonia. 2 hours after being admitted. Brownish red spots started to appear on their cheekbones. A few hours later, the patients would develop significant cyanosis. The symptoms spread from their ears across their entire faces, so much so that you couldn't tell whether they were white or black. The hospital was filled with a foul stench. It really means a lot to us. For the patients who couldn't get out of bed or even take care of themselves, their own waste soiled their bed sheets and clothes with a pungent odor. There was blood everywhere on the sheets on their clothes. Some were coughing up blood, while others were bleeding from their noses and even their ears. Many of the soldiers were just teenagers. Over 6,000 people were crammed into a hospital with only 800 beds. These were extraordinary times. Or young men in their early 20s. They should have been healthy and rosy-cheeked, but now their faces were blue. The color on their bodies was like a brand left by death itself. In some soldiers' letters, they wrote that this change happened just in the few hours before death, which was absolutely horrifying. Perhaps you can bear to see 1 or 2 or even 20 people die. And in a way, it was also a product of the First World War. But now you could only watch as these poor souls suffered miserably before their deaths. On average, more than 100 people died each day. In almost every case, pneumonia meant death. We had already lost a huge number of medical staff. For a while, there weren't even enough coffins, and bodies were piled up like small hills. We can't look at this global pandemic without considering its historical context. The scene was even more shocking than the fields of bodies on the battlefields of France. A warehouse was cleared out to be used as a morgue. The bodies of fully dressed soldiers were placed on both sides. When they tried to move the bodies, blood would even gush from the noses of the dead. Anyone who witnessed this scene would be horrified. Goodbye, my old friend. In July 1914, and the illness progressed with terrifying speed. At the same time, the media wasn't sitting idle. They were busy telling the public not to be afraid. The flu is an old friend, they said. It's not dangerous. Will completely shatter everything you thought you knew about influenza. The city even decided to hold a massive parade to raise money for the war. Now pay close attention. This parade would become a major turning point in Philadelphia's epidemic, taking things from bad to catastrophic. The parade was expected to have several thousand participants, with the number of spectators reaching into the hundreds of thousands. The parade organizers even issued a statement if anyone refused to donate. Before we start, time for our usual shameless plug, or if their attitude influenced others not to donate, they would be considered a German sympathizer. Anyone unwilling to lend money to the government was unworthy of being an American citizen. But considering that some flu cases had already appeared locally, a few responsible infectious disease experts naturally understood the consequences of such an act. Therefore, they tried everything in their power to create public pressure to stop it. Beds filled every corner and every crack. If you like our video, they told newspaper reporters that the gathering would spread the flu and could be deadly. But not a single newspaper published his warning. After all, such a comment would be bad for morale. The day before the parade, Philadelphia's hospitals admitted over 200 more patients infected with the flu, 123 of whom were civilians. The parade organizers were feeling the immense pressure from people demanding the parade be canceled. This pressure, remember to smash that like button and show some support, came from the opposition of ordinary citizens, from the concerns of the medical community, and from the fact that the Army had already canceled the draft because of the outbreak. But at that very moment, a researcher claimed he might have made a breakthrough in identifying the papers that it really means a lot to us. Rallies would be held as scheduled. On September 28th, the participants in what was the largest parade in Philadelphia's history marched with their heads held high. The procession stretched for more than 3 kilometers with bands, colorful banners, and soldiers. These were extraordinary times, filling the entire route. Hundreds of thousands of people crowded along the parade route, pushing and shoving. It was a boisterous scene. The encouraging cheers of the onlookers filled the streets. In Philadelphia, 2 days after the parade, the medical community's worries finally became a reality. The parade organizers then issued a grim statement. And in a way, the epidemic occurring among the citizens may be similar to the situation at the naval base and military camps. The flu had indeed broken out in the city. Within 72 hours of the start of the epidemic, all the beds in the city's 31 hospitals were completely full. Patients began to die. On the 3rd day of the epidemic, in that single day, the number of people who died from the flu exceeded 100. That number later grew to double, triple. It was also a product of the First World War. 4 times, 5 times, and 6 times that. The number of daily deaths from the flu surpassed the total number of deaths in an average week in Philadelphia. In just 10 days, the epidemic went from a few hundred of the city's poor getting sick a day with only 1 or 2 deaths, to tens of thousands of people getting sick daily, with hundreds of deaths every day. On October 5th, doctors reported that on that day, we can't look at this global pandemic. More than 250 people had died from this flu. So the paper citing the Bureau of Public Health reported that the flu had reached its peak. But the next day, another 289 people died in Philadelphia. And the paper said again that health officials were fully confident, convinced that the peak of the flu had passed. Over the next 2 days, the daily death toll exceeded 300. And again, the papers reported, in isolation from its historical context, that the death toll had reached the highest point of this catastrophe. We have reason to believe, they said, that from now on, the flu will soon be over, and the mortality rate will steadily decrease. But the very next day, the death toll hit another new high. Philadelphia's morgues were holding 10 times their usual number of bodies. There was no more room for the dead. The bodies of those who died at home were simply left where they were. In July 1914, World War I broke out. When they died, their noses and mouths would often ooze a bloody fluid. Families would cover the bodies with ice, but even then, the bodies would still rot and give off a horrible stench. The bodies were wrapped in sheets and shoved into corners, often left there for days on end. The crushing sense of horror grew with each passing day. People were too sick to cook, too sick to function, and far too weak to even move the bodies of their dead family or friends from their beds. They had no choice but to lie in the same bed with the dead. The symptoms of the dying were horrifying, bleeding from their eyes, ears, nose, and mouth. The U.S. president at the time, Woodrow Wilson, some of the dead wore looks of extreme agony while others had been taken by madness before they died. Usually 1 or 2 people in every family died, and it wasn't uncommon for entire families to be wiped out. The epidemic that ravaged Philadelphia was playing out across the United States and all over the world. During the 1918 flu outbreak, the small town of Wales in western Alaska, with a population of over 300, lost half of its people. In the small settlement of Brevig, out of 80 residents, only 8 survived. And here's a bit of foreshadowing. These flu deaths near the Arctic Circle would actually become a key factor in humanity's fight against this virus in the near future. Any guesses why? But the most terrifying numbers came from India. Just like everywhere else, India was hit by a wave of the flu in the spring. And similarly, this spring wave was relatively mild. Nurses and doctors were exhausted from trying to care for the sick, resisted pressure from home. In September, the virus came roaring back to Mumbai. But this time, just like elsewhere, it was anything but mild. But India was different. Here, the flu unleashed its truly terrifying power. Across all of India, only death remained. Trains would leave a station full of living people, only to arrive at their destination full of corpses. The mortality rate for Indian soldiers who caught the flu was as high as 22%. One hospital in Delhi took in over 13,000 flu patients, and more than 7,000 of them died. A doctor wrote that a case of flu deaths near the Arctic Circle just so happened to become a key factor in our fight against keeping the United States strictly neutral. This virus in the near future, can you guess why the most terrifying numbers came from India? Just like other places, India was hit by a wave of the flu in the spring. And again, like elsewhere, this spring wave was relatively mild. In September, the virus came roaring, back returning to Bombay, but this time, just as everywhere else, it was no longer mild. But India was different from other places. In 1915, here, the flu. For over 2,000 years, this was how people treated most diseases. As for the mainstream treatments, if you've ever seen a period drama, this will sound familiar. The so-called bloodletting therapy is the practice of draining blood from the body. Many had collapsed or were already at death's door, despite publicly expressing his outrage to clear it of toxins and pathogens, before any useful drugs or treatments were discovered. Bloodletting was pretty much all they had. This is a very ancient method. The famous Greek physician Galen even mentioned in his writings that this was an important way to cure diseases. And here's another fun fact for you. Ever heard of the Lancet? Still decided? It's the world's top medical journal. Well, a Lancet is the main tool used for bloodletting. However, bloodletting therapy was never successful. If you don't believe me, just ask George Washington. In the first few decades of the 20th century, this method was still widely used to treat influenza. And not just by some shady doctors, but even on the front lines of World War I, Army medics would use it to treat soldiers. They claimed it was a cure to swallow his anger and stay out of the war. And they rarely ever questioned the therapy itself. Even if a patient died from bloodletting, after giving it some serious thought, they would just conclude that the disease must have been too advanced. Other doctors advocated for giving Flu patients strong laxatives like raw mercury. Word was it helped relieve fevers. Some even recommended drinking champagne. The theory behind how champagne saved lives was supposedly that nothing could snap a flu patient, merely demanding that Germany promise to limit its submarine warfare. With a fuzzy head back to their senses, better than a glass of fizzy champagne. So weren't there any slightly more normal treatments? Yes, of course there were. For example, aspirin. And aspirin did in fact help relieve flu fevers. Hearing this, you might be thinking that treatments were finally on the right track. Right? But this seemingly, he even openly used, valuable advice actually became a deadly cause of death during the influenza pandemic. Death's biggest accomplice. The key reason for the problem was precisely that most doctors at the time, when it came to the safe dosage of aspirin, really had no clue. The symptoms of an aspirin overdose start with ringing in the ears, and then progress to sweating, dehydration, and shortness of breath. An excessive dose causes fluid to rush into the lungs. He kept us out of war as his campaign slogan, which is extremely similar to the actual symptoms of the flu. It then enters the brain, causing cerebral edema, which leads to confusion, coma, convulsions, and death. During the flu pandemic, it's likely many people actually died from an aspirin overdose. There's a record of a doctor in London whose instructions for a patient were to pump the patient full of aspirin at a dose of 1.3 grams every hour for 12 hours straight for the 1916 election, and then another dose every 2 hours. Now go and look up the safe dosage for aspirin today, and you'll find the units of measurement have completely changed. That's when you'll realize just how terrifying that dosage was. In September of 1918, the U.S. Surgeon General announced that aspirin had been successfully used abroad to relieve symptoms of various diseases, warning voters that, but the reality was in the month that followed, the death toll from the flu reached its absolute peak. And there were even more outlandish treatments. Due to the war and the epidemic, the general atmosphere was filled with a sense of helplessness and despair. Some clever people began inventing their own treatments. For instance, there was a small town called Falmouth. The villagers there, if they discovered their children were sick, if you choose my opponent, they wouldn't take them to a hospital. Instead, they'd take them to the gasworks to inhale coal gas. The parents believed the gas could kill the pathogens and alleviate their children's suffering. And don't laugh just yet. The effectiveness of this method was actually studied statistically later on, and the data backs this up. At a naval patrol base, the flu infection rate was 40%. Meanwhile, at a local mine workers, you are choosing war. Were exposed to toxic fumes containing nitric acid, and the flu infection rate was only 11%. Other mine workers were exposed to explosives and black powder. And for these lucky individuals who inhaled the toxic fumes, the flu infection rate was even lower, only 5%. There was just one problem. The toxic fumes didn't just kill pathogens. They also happened to kill people. Everywhere, patients were coughing up blood. As it turns out, from day one of the outbreak, scientists had been working frantically in their labs. With their backs against the wall, this was the most desperate situation they had ever experienced. Most of them lowered their standards of evidence and optimistically latched onto the work of Pfeiffer. As the prized protege and son-in-law of Koch, he might have left something out. The scientific director of the Berlin Institute for Infectious Diseases, a high-ranking general in the German medical corps, and a giant in the scientific community. As early as 1892, he had announced that he'd identified the cause of the disease, a tiny gram-negative bacterium, that he called the influenza bacillus. That was right after the Russian flu had just subsided. And even though other researchers at the time, so being the helpful person I am, I decided to add, found this bacterium next to impossible to culture. And even though Pfeiffer's own team, after inoculating monkeys with the bacillus, had consistently failed to actually give the monkeys the flu, what did any of that matter? His initial discovery was enough to convince the medical community and the entire world. The second half for him, if you choose me, it became the mainstream theory, convincing enough for the medical establishment. Many scientists believed its conclusion and even treated it as an axiom. As long as the majority of medical authorities identified the influenza bacillus as the pathogen for influenza, then that was that. Therefore, very few people dared to challenge the authority of Koch's school of thought, and very few dared to question him publicly. This might also explain why researchers, in July of 1918, you're still choosing war, Wilson, after arriving at Camp Funston, ignored a particular fact. The influenza, perhaps the most important, were Avery at the Rockefeller Institute, Park and Anna Williams of the New York City, Department of Public Health, and Lewis and others in Philadelphia. Initially, every single one of them, without exception, followed the lighthouse that was Pfeiffer. It's just that some along the way, they announced in January 1917, chose to follow facts rather than authority, and adjusted their course. while others continued to follow authority, selectively ignoring the facts, and spent their entire lives heading in the wrong direction. Avery was born in Montreal and grew up in New York, the son of a pastor at a church in the city. And although he looked kind, friendly, and sociable on the outside, that they would resume, he said he was born for research. His first step, like many other researchers, was to look for the influenza bacillus. He knew this bacterium very well, and he knew just how difficult it was to culture. At Camp Devens, from the 30 autopsies he conducted on soldiers, he found the influenza bacillus in 22 of them. This seemed to confirm that the flu outbreak at Camp Devens was caused by the influenza bacillus, unrestricted submarine warfare. However, his own findings started to raise some doubts, because in 7 of the autopsies, he found no signs of any bacterial invasion. Yet the soldiers' lungs were still damaged, and he found other potentially fatal bacteria in their throats. But those bacteria never matched the profile of the influenza bacillus. This suggested that the influenza bacillus might not be the cause of the disease, but that was the only accepted conclusion at the time. So he was stumped. In early October, he returned. Many others were bleeding profusely from their ears and noses against neutral and merchant ships to cut off British and French supplies, to the Rockefeller Institute, and listened to reports from dozens of other researchers from across the country and the world who were also hunting for the influenza bacillus. Among them were some reports from those who had failed to find it. But under the influence of authority, it was easy for people to blame the failure to find the bacillus on technical errors. After all, it was one of the most difficult microorganisms to cultivate. Wilson, at the end of his rope, decided, besides his own discoveries, left too many unanswered questions, leaving him unable to conclude whether the flu was really caused by the influenza bacillus. After the great influenza pandemic ended, he continued to study the influenza bacillus for years, but more and more evidence only deepened his suspicions. After the great influenza pandemic ended, he continued to study the influenza bacillus for years to hang on just a little longer. Then, but more and more evidence shows that Haemophilus influenza wasn't the real cause of the flu. He slowly started to accept this idea and shifted his research focus to studying pneumococcus, because the flu itself isn't deadly. What's deadly is the pneumonia it causes. That's the real culprit that causes death. The Zimmerman telegram incident happened. He dedicated all his time to pneumonia research once again. He spent the rest of his life studying pneumonia, and in the process he accidentally discovered the role of a so-called transforming principle in heredity. In November of 1943, he, along with several other scientists, submitted a paper to the Journal of Experimental Medicine titled Studies on the Chemical Nature of the Substance Inducing Transformation of Pneumococcal Types. This paper describing transformation induced by a fragment. According to the intercepted document, Germany promised to return new of deoxyribonucleic acid, isolated from type 3 pneumococcus, explained that the substance that transformed non-encapsulated pneumococcus into encapsulated pneumococcus was DNA, thus proving that DNA carries genetic information. Actually, DNA had already been isolated back in the 1860s by a Swiss scientist. It's just that at the time nobody knew its function, and geneticists ignored it because the molecule seemed way too simple, Mexico and other, to possibly have any role in genes or heredity. 10 years later, Crick and Watson also explained the importance of Avery's work in their classic work, The Double Helix. So to sum it up, a Swiss scientist discovered DNA. Avery proved that DNA carries genetic material. Building on the work of these two, Crick and Watson went on to discover the structure of DNA and its complexity, territories to entice Mexico into joining the Central Powers in World War I, showing it was sufficient to carry an organism's genetic information. Avery proved that DNA carries genetic material. Building on the work of these two, Crick and Watson went on to discover the structure of DNA and its complexity, showing it was sufficient to carry an organism's genetic information. What we can learn from this story is the importance of standing on the shoulders of giants. Unfortunately for us, Crick and Watson won the Nobel Prize and teaming up against the United States, and are remembered by the world, while Avery didn't win and is certainly not remembered by the world. And what's even more ridiculous is that before Avery discovered and proved that DNA carried the genetic code, the Nobel Committee had once for his life's work and contributions to the knowledge of immunochemistry seriously considered awarding him the Nobel Prize, but not long after, the fed-up Wilson decided he'd had enough. His revolutionary paper was published. The paper, far from helping him win the Nobel Prize, actually made the Nobel Committee think the paper was too revolutionary, too shocking, and they were unwilling to be implicated in awarding him for his discovery, not unless other people confirmed it. I've only ever heard of people winning prizes for publishing papers. This is the first time I've ever seen someone publish a paper and lose a prize over it. But I'd call him a hero behind the scenes on April 2nd, just like the Sutton brothers behind Garner. they too should be remembered by the world. Lewis was the son of a doctor, grew up in Milwaukee, and completed his medical training at the University of Pennsylvania in 1904. Even before leaving medical school, he knew that the lab was where he wanted to spend the rest of his life. Later, an outbreak of polio led Lewis and a colleague to a flawless collaboration. Their work on polio, even strong soldiers were carried into the crowded wards and placed on beds. Wilson finally presented his was a model of efficiency and quality, proving that polio was a viral disease, and it's still considered a milestone in virology to this day. This research also made Lewis one of the world's leading virologists. However, when it came to influenza research, Dr. Lewis was not so fortunate. From the very beginning, he wondered if a filterable virus might be causing the flu, but he couldn't explain what a filterable virus was. And to search for such a virus, that seems impossible to us. And what's more, a growing body of evidence was pointing to a filterable virus as the likely cause. Unfortunately, back then research on human influenza, there was still a lack of reliable animal models, and the technology to cultivate viruses in living cells was also missing. Therefore, no researcher could obtain solid proof that the pathogen causing the flu was a virus. The entire nation, this forging process, but their extraordinary vision and their courage to challenge authority were actually quite rare for that time. In 1931, a scientist named Shope wrote in his paper that he had found the cause of influenza in pigs and that it was caused by a virus. Shope's paper caught the attention of a British scientist by the name of Andrew S. In 1933, during a small human influenza outbreak in Britain involved cramming millions of young people, Andrew S., Laidlaw, and Smith largely followed Shope's methodology. They filtered fresh human samples and used them to infect ferrets with the flu. This finally proved that the pathogen for human influenza was a filterable microorganism, a virus, not a bacterium. More than 60 years later, into the extremely tight quarters of military barracks. Under the leadership of molecular pathologist Taubenberger, scientists finally obtained the complete genome sequence of the virus from the lungs of a woman who died of the flu in Alaska. Obtained the complete genome sequence of the virus. Because she was buried in permafrost. When they exhumed her body, they discovered her lungs had not decomposed. This finally gave humanity the chance to unveil the mysteries of the Spanish flu virus. The research was published in 2005 for pre-war training. Their men, and the results were astonishing. When the 8 gene sequences of this viral strain were compared with the sequences of other influenza strains, scientists found that among the influenza strains that had previously infected humans, So here we'll mainly talk about type A, also known as the influenza A virus. The type A influenza virus is also an RNA virus. It needs to infect living cells to replicate itself. This virus is about 100 nanometers in diameter, slightly smaller than the rabies virus, but larger than the rhinoviruses that cause the common cold. If we zoom in, because in the extremely crowded barracks, it looks a lot like a dandelion covered in tiny spikes and mushroom cap-like filaments. The spike-like structures are made of a protein called hemagglutinin. After the virus is inhaled into the lungs, the hemagglutinin attaches to the surface of cells, tricking the cell into absorbing it. Once inside the cell, the virus's envelope dissolves and releases its genetic material, which then invades the cell's nucleus. It's not just violations that happen. There they hijack the normal cellular machinery and instruct the cell to produce millions of copies of viral particles. Then, these newborn particles move to the inside of the cell membrane, just like bubbles in a boiling pot. Because they're locked onto the surface, they need to break free as soon as possible to invade other healthy cells. This is where a protein called neuraminidase comes into play, but also the extremely terrifying spread of disease, helping the new viruses escape the host cell and invade other cells. When we talk about H1N1 flu viruses, the H stands for hemagglutinin, and the N stands for neuraminidase. Hemagglutinin and neuraminidase can also be divided into multiple subtypes. For example, the numbers in H5N1 refer to specific subtypes. In mammals, like small copying errors can occur, causing the genes for the H and N molecules on its surface to mutate. Simply put, this gradual mutation is called antigenic drift. In addition, type A viruses can also spontaneously exchange genetic material. For instance, if an intermediate host is simultaneously infected with an avian flu virus and a mammalian flu virus, the genes of the two viruses can mix together, creating a completely new virus. Since 2005, this flu pandemic can be divided into 3 waves. Scientists began a brand new flu virus. This process is called antigenic shift. The flu virus is constantly changing. Every time it changes the proteins it codes for, it's completely new to our immune system. And this is the main reason why we have to update the flu vaccine every year. The Spanish flu. The reason it was called the Spanish flu